Hello everyone, section 1.5, measuring and constructing angles. Example 1, give another name for each angle. So angle DEB is angle 4. Angle CBE, so CBE is angle 8. Angle BEA is angle 3. Angle DAB is angle 1. Angle 7, we have a bunch of choices. Let's go with angle DCB. I could have gone with ECB, could have gone with ECA. I had a lot of choices on that one. Same. Actually, I only have two choices on angle 9, ABE or EBA. Okay. Example 2, write 3 names for the angle. So we have angle 3, angle U. I can do this because there is only one angle U. I could not have done that for angle A here, because there are 3 different angle A's in this picture. There's angle 1, there's angle 2, there's angle EAC. All 3 of them have A as a vertex. I'm going to also call this angle VUT or TUV. Okay. Example 3. Find the measure of each angle and classify each angle. RQU, so RQU. So this is at 0. We're going to come over here and we're going to read from 0 all the way up to 125. 125 degrees. And we're going to classify that angle as obtuse. Because it's bigger than a 90. TUQ, TUQ. So we're going from 90 to 125. So a 125 minus 90 is going to give us a 35-degree angle. And that type of an angle, which is less than 90, is acute. Angle UQS goes from 35 degrees up to 125 degrees. 125 minus 35 is 90 degrees. And that's a right angle. Here we have a construction of how to copy an angle. And I suggest that you go to my videos on how to copy an angle, this particular construction, so that we can use that. Example 4, identify the congruent angles. So it's hard to see in the picture, but these markings indicate that angle DEG is congruent to angle FEG. In the same picture, we have 2 arcs here and 2 arcs here, indicating that those angles are congruent. That's angle EDG, congruent to angle EFG. Measure of angle EDG is 40 degrees. What's the measure of angle EFG? EDG and EFG are congruent. They're congruent, so their measures are equal. Measure of angle EFG is equal to 40 degrees. Now notice, measures are equal, angles are congruent. Don't mistake your notation, don't mix it up. Measures are equal, angles are congruent. Okay, now we're going to do some constructions. Here in example 5. We're going to use angles X and Y to do these constructions. First, we're going to add angle X to angle Y. So first I need to make a copy of angle X. Hopefully you followed my video on how to make a copy of an angle. First we're going to make an arc. Actually, first I'm going to make a segment. Let's go from here. A ray, actually. Now, from that ray, I'm going to make the exact same arc that I just made. Now, I'm going to go back to this angle, and I have to set my radius to the intersection of the arc and the two sides. And I don't know if you can't see it in the camera, but that is right over the intersection. I'll come back here to this intersection of the side, draw an arc, and where these two arcs intersect, I'm going to connect. This is angle X degrees. Now, coming off of this, I have to make a copy of angle Y. So this is a little bit harder to do because if I make an arc way down here, I won't be able to set my radius equal to that length. So I'm going to make the arc a little bit farther out here, just a little. And we'll come here. Make the copy of that same arc. Now I'm going to set my radius to the length of that arc. You'll probably be able to see it in the camera this time. Maybe not. But that is right over the intersection. Set my center on the intersection there. Draw my arc. Connect through. This is Y degrees. And this, highlight. This arc here is X plus Y. Okay. Now, we're going to do the same thing, only we're subtracting. So, I'm going to make another ray to start with. And I'm going to make another copy of angle X here. So I'm going to use the arc that I already used earlier. Hard to see. Center of my compass. Set it to the length of the original arc that I had. Come down here. Make a copy of that arc. Set my radius now to the length of the two intersections. Again, I know you can't see it, but that is the right length right there. Back over here, draw my arc, come through. This is angle X degrees. Now, different this time, I'm going to actually make a copy of angle Y inside of this, so I'm going to subtract. So I'm going to make my copy. Let's set my radius again to the arc that I made earlier for part A. Set my length and my radius to the length of the intersections. Down here. Draw my arc. Go through. So this one here is angle Y. So now I'm going to highlight, because there's a bunch of different angles drawn in here. Which one is X minus Y? Oops. There's one of the rays. Here's the other ray. And this one here is X minus Y. So that is example 5, A and B. Example 6. Given the measure of angle PQR is 102 degrees, find the measure of angle SQR and the measure of angle PQR. Well, what can you tell me about these two angles? According to the angle addition postulate, they add up to be angle PQR. In other words, measure of angle SQR plus the measure of angle PQR equals the measure of angle PQS. Equals the measure of angle PQR. So the measure of angle SQR is 9x plus 11, plus measure of angle PQS is 7x minus 5, and that's equal to 102 degrees. A little bit of algebra. 16x equals 107 minus 11, 90. I think. And now I've got to divide 96 by 16, so x is equal to 6. And we're going to find the measure of angle SQR, which is 6 times 9, so 9 times 6 plus 11. 9 times 6 is 54, plus 11, 65 degrees. This is equal to measure of angle SQR. And I know this says here, this is a typo. We're looking for the measure of angle PQS. We're not looking for the measure of angle PQR, because we're given that one. We're looking for the measure of angle PQS. The measure of angle PQS is equal to 7 times 6 minus 5, 42 minus 5, 37 degrees, or 102 minus 65, which is 37 degrees. Alright, so that's part A. Part B, no picture for part, sorry, the picture's here. Measure of angle AOB is 4x plus 3. Measure of angle BOC, 7x. And the measure of angle AOD is 16x minus 1. Now, notice we have congruent marks here, so this is another 4x plus 3. And the whole thing is 16x minus 1. So again, according to the angle addition postulate, measure of angle AOB plus the measure of angle BOC plus the measure of angle COD equals the measure of angle AOD. So I'm going to substitute in 4x plus 3 plus 7x plus 4x plus 3 equals 16x minus 1. 8x, 15x plus 6 equals 16x minus 1. Subtract 15x, add 1. X equals 7. Solve for x. So there's x equals 7. X is 7, and the measure of angle AOB is 4 times 7 plus 3, or 31 degrees. Measure of angle BOC is equal to 7 times 7, or 49 degrees. And the measure of angle AOD is equal to 16 times 7 minus 1, which is equal to 111 degrees, which I believe the answer key has the wrong answers on it. These are correct. And I can check 31 plus 31 is 62, plus 49 is 111. Part C. Draw 3 angles, angle AOB, BOC, and AOC, for which it is not true that the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. So, let's draw 3 angles. And O is going to be the vertex for all 3 of these angles. Angle AOB, let's go with A here and B here. And BOC, let's go with C right here. Slide that up, sorry. So now, AOB plus BOC is most definitely not AOC. AOB minus BOC would be AOC. But if I add them together, it doesn't work out. So there's an example for part C. Problem number 7. Use angles x and y to construct an angle having the following indicated measure. So here's angle x, here's angle y. I want to do an angle that is 3/4 of angle x. I should say you should follow the videos on bisecting an angle, because that's how we're going to do this one. If we bisect angle x, and I can do that right on this. I'm not going to make a copy like I did before. So let's bisect angle x here. First we draw an arc. Now from this arc, from the end, one of the endpoints of this arc, I'm going to draw another arc, and as long as I'm beyond the midpoint, or the mid bisector, the bisector of this angle, as long as I'm farther along than that, then I've got a good place for this arc here. I'm going to draw. Keeping the same radius, I flip over to the other intersection. And I draw another arc. It's going to intersect the last one I just drew. And draw my bisector right through there. So this is my angle bisector. So this is now half of x, this is now half of x. I now have to bisect either this one or this one. I'm going to bisect this one down here. So again, I need to cut this angle in half. Continue that arc. Come over here. Use the same radius. This is now bisected, so this is 1/4 of x, 1/4 of x, and half of x. So when I add 1/4 plus a half, I get right here to be 3/4 of x. Okay. Now we're going to do 180 minus 2y. Alright, so to do that, I am going to make a copy of this angle y. I'm not going to use that angle y. So we're going to start with a line. By 180 degrees right here. And I'm going to make a copy of angle y over here. So, and I'm going to make this arc long enough so that I'm going to be able to do 2 angle y's here. So this arc is significantly long. Maybe a little bit further. Perfect. Set my radius over here to the 2 intersections. Come over here. So that's 1 angle y. If I do it again, This is 2 angle y's. So this arc right here, or this angle right here, is 180 minus 2y. That's example 7. Example 8. Ray VB bisects angle AVC, and the measure of angle AVC is 158 degrees. Find the measure of angle BVC. I'm going to do a quick sketch. Nothing fancy. Angle AVC. Angle bisector VB is in there. Angle AVC has a measure of 158 degrees. Those are congruent. So, measure of angle 2 times the measure of angle BVC equals measure of angle AVC. BVC plus another angle that's congruent to BVC is equal to AVC. 2 times the measure of angle BVC equals 158 degrees. Divide by 2. Measure of angle BVC equals 79 degrees. Okay. Ray AL bisects angle KAT. Indicate that in my diagram. You want to get used to marking up your diagrams all year long. Find the value of x for each of these different scenarios. Okay, this is each new problems. So I know angle 1 is congruent to angle 2. 1 plus 2 plus 3 is equal to 180, so on and so forth. Okay, so if angle 1 is x and angle 3 is 4x, then I have x plus 4x is equal to 180, or 6x equals 180, x equals 30. Part A, x equals 30. Part B, angle 1 is 8x plus 3, angle 2 is 6x plus 9. They're congruent. So 8x plus 3 equals 6x plus 9. A little bit of algebra. 2x equals 6, x equals 3. There's part B. Part C, angle 1 is 5x minus 5. Angle 2 is x plus 19. Again, they're equal. 5x minus 5 equals x plus 19. 4x equals 24. X equals 6. Angle 1 is 3x minus 7. Angle 3 is 128. 3x minus 7 plus 3x minus 7 plus 128 equals 180, or 2 times 3x minus 7 plus 128 equals 180. 2 times 3x minus 7 equals 52 divided by 2, 3x minus 7 equals 26. 3x equals 33. X equals 11. Example 10. Draw any segment AB. Okay. Here's A. There's B. There's segment AB. Make sure we're focused. Good enough. Okay. Construct segment XY so that XY is equal to AB. Okay. Well, I'm going to need a line, array to do that in front. This will be point X. I'm going to set my radius equal to AB here. Where's B? There it is. And where that intersects my ray, that's point Y. So I've now constructed XY, same length as AB. I don't think my pen is working very well anyway. There we go. We got a little bit of ink left. Okay. Now, part B, using X and Y as centers and keeping the radius of AB. So the radius that I just used, I'm going to draw two arcs that intersect. I'm going to have them intersect up here. I could have them intersect down below, but I have open space up here. So that's where I'm going to draw my arcs. Oops. I'm going to intersect 1 and 2. Label this point Z. Draw XZ and YZ. There's XZ. There's YZ. Now, because I used the radius that was the same as AB, XY is the same as AB, this radius here is the same as AB, this radius here is the same as AB, all three of these are congruent. So what kind of a triangle is triangle XYZ? Equilateral. That's an equilateral triangle. Now, explain how you could construct a 30-degree angle. Well, using what I just did in example 10. I'm not going to redo this whole thing. I'm going to use example 10. I've just constructed an equilateral triangle. The fact that it's equilateral makes it also equiangular. The fact that it's equiangular means that each of these angles are exactly the same. They add up to 180, so each one is 60 degrees. I'm not going to write 60, but it is 60 here as well. If I bisect this angle, this 60-degree angle, I will have constructed my 30-degree angle. So there's my explanation on how you can construct your 30-degree angle. Construct an equilateral triangle, like we did in example 10 here, and bisect one of the angles. So let's bisect it. Let's do it. And I'm going to bisect here. I have 30 degrees here, 30 degrees here. I have constructed two 30-degree angles. And that's all of the section. Thank you very much.